All right, let's get right into it. We are standing on the edge of a huge change in healthcare. I'm talking about a tech revolution that's taking these incredibly powerful diagnostic tools out of the big labs and, you guessed it, putting them right into our own hands. And that's exactly what this explainer is all about.
You know the drill, right? You go to the doctor, they take a sample, and then you wait. It's that anxious, slow, inconvenient process in a world where everything else happens instantly. But what if getting that critical health information was as easy as just checking your phone? And this is really the core of the shift. The old way is centralized. It's slow, it's often invasive, nobody loves getting blood drawn, and it takes trained pros. But the new promise is what we call point-of-care testing, or POCT. This stuff is right there with you, it's instant, super user-friendly, and way less invasive. Think using sweat or saliva instead of blood. This isn't just a tiny improvement, it's a total reimagining of how we get information about our own bodies. Now, for these new gadgets to actually work in the real world, they can't just be convenient. They have to be rock solid. The World Health Organization laid out a gold standard for them, and it's called the Reassured Criteria. I mean, look at this list. Affordable, sensitive, user-friendly, fast, tough, you get the idea. And the newest additions are R for real-time connectivity and E for ease of collection. That tells you everything you need to know about where this is all heading. Seamless, modern healthcare. So here's the game plan for this explainer. We're going to start with that big picture, then zoom way in on the core tech, this amazing little biological switch. We'll see how we make it smart, how we make it work without any batteries, and then we'll look at the mind-blowing stuff that's already happening before zooming back out to see what it all means for the future of our health.
Right, so this is what it's all about, making healthcare faster, easier to access, and way more personal.
So how is any of this even possible? Well, at the very heart of this revolution is a tiny, microscopic piece of electronics. It's called a Bio-FET, and it's pretty much the little engine that could, driving this whole concept forward.
So a Bio-FET, that's short for biosensor field effect transistor, is basically a tiny electronic gate. Its whole job is to take a biological event, like a protein latching onto a surface, and turn it into an electrical signal that we can actually read and understand. You can think of it like a translator between the world of biology and the world of electronics.
Okay, the best way to think about this is a simple lock and key. It all starts with a normal transistor. That's our gate, controlling the flow of electricity. Now, we stick a very specific biological receptor onto that gate. That's our lock. The molecule we're looking for, say a stress hormone floating around in your sweat, that's our key. When that one specific key finds and fits into our lock, it actually changes the electrical field and messes with the flow of electricity through the gate. We measure that change, and boom. Just like that, we've detected our molecule.
But, a switch is only as good as what it's switching. The real genius of the Bio-FET is how versatile it is. By just swapping out that biological lock, we can pretty much program it to detect almost anything we want.
And we have a few different brains we can give these sensors. We can use antibodies. That's the tried and true industry standard you'd find in something like a pregnancy test. Or we can use something called aptamers. These are custom-built little strands of DNA or RNA that are super stable and reusable. And then there's the cutting edge, using CRISPR-based systems to hunt down one single unique genetic sequence with just unbelievable accuracy.
Okay, so we've got a tiny, brilliant sensor. But how do you power it? Especially if the goal is a cheap, disposable patch you can just wear and forget about. I mean, batteries are bulky, they're expensive, and they're a nightmare for the environment. This was the next huge challenge to overcome.
And here's the problem. The energy just floating around us is, well, it's really weak. Things like indoor light or your own body heat can only give you power in the microwatts. But a little sensor needs power in the milliwatts. That's 1,000 times more power. So trying to harvest that ambient energy, it's just not going to cut it.
But what if the power source wasn't all around us? What if it was something we carry with us everywhere, every single day? As it turns out, the solution is probably in your pocket right now.
It's NFC, near-field communication. Yep, it's the exact same tech that lets you tap your phone to pay for coffee. See, when your phone gets close to an NFC tag, it creates this magnetic field that does two things. It exchanges data and, this is the crucial part, it actually generates an electric current in the tag's antenna. It wirelessly sends both information and power.
And we're not talking about a trickle of power either. A standard smartphone can push out up to 16 milliwatts through NFC. That's way more than we need. So this means you can just tap your phone to a sensor patch, and in that single action, you power it up, you take the measurement, and you get the data sent right back to your phone. All of it, no batteries required.
All right, so we've got the theory down.
A tiny biological switch, we've programmed it with a smart lock, and we're powering it wirelessly with our phones. Now let's look at how this is actually moving out of the lab and into our lives.
Let's start with something we're all familiar with, the glucose monitor. For decades, it's been this clunky, battery-powered thing that needs a painful finger prick just to get a drop of blood. Now look at the difference. We have battery-free, NFC-powered patches that can measure glucose without any needles, just from sweat or the fluid right under your skin. It has gone from a painful one-time reading to a simple, wearable patch that can monitor you continuously. That's a game changer. And this goes way beyond just glucose. For athletes, imagine tracking lactate for muscle fatigue or electrolytes to know exactly when to rehydrate. For everyday life, you could monitor your cortisol levels to actually see your stress. It can even help patients by tracking their medication levels, like levodopa for Parkinson's, making sure their dose is perfect. The possibilities even stretch to things like food safety, with a sensor right on the packaging telling you if it's gone bad. So, where is this all headed? These individual sensors are amazing, but they're really just the beginning. They're the building blocks for a much, much bigger interconnected vision for our health.
And that brings us to the Internet of Medical Things, or the IoMT. The idea here is that all these smart patches, smart watches, and other devices aren't just going to work on their own. They'll form a network, constantly collecting data, sending it to our phones and to the cloud, where it can all be analyzed to give us and our doctors a truly complete real-time picture of our health.
And that kind of brings us to our final thought here. For the very first time, we are giving our bodies a direct line of communication to our digital world. We're essentially creating a language between our own biology and our technology. So the question we're left with is a pretty profound one. If your body can finally truly talk to your phone, what is it going to tell you?